Hello class, this is a video tutorial on dilations of functions part 2. In the previous video we saw we saw how to achieve vertical dilations as well as horizontal dilations and a few examples on a function of a parabola. In this video we're going to see that it's actually possible to apply these dilations to non-functions. So let's get straight into the example here. Let's apply the following dilation to the circle x squared plus y squared equals 4. Just so that we can remember the vertical dilations. Okay, we replace, if we have some expression y equals f of x, we can replace, actually let me take a look back here. The vertical dilation, we replace y with y on a, and for the horizontal we replace x, f of x, with f on x on b, some factor of b. So let's get straight into it. So now it might be a little bit confusing because there is no function present, but we can still do the same action of replacing y with y on a and x with some factor x on b. So let's enlarge this by a factor of 2. Just so you know, an enlargement is the same as a vertical and horizontal dilation by the same factor. Okay, so we're going to take our function, our relation, not a function. Here's our relation. And we're going to replace x with x on 2 whole squared plus, we're going to replace y by the same factor, y on 2 whole squared equals 4. Expanding both of these, we get 1/4 x squared plus 1/4 y squared equals 4. Multiplying both sides by 4, we get x squared plus y squared equals 16. This is a circle, the exact same circle with the same center. However, this time we have a radius of 4. A radius of 4. So now originally this is a radius of 2. The radius now is going to be, if that's 1, 2, that's 3 and 4 all the way at the edge here. So this is now going to look like, that is a big circle, something like this. Excellent. So this is now the dilation of the new circle. Let's enlarge this by a factor of 1/4. Okay, so this time let's take a look. Let's duplicate this. It's a very similar style of question, except it's the same here. It is a vertical and horizontal dilation, except this time the factor we are using is going to be 1/4. So we replace x with x over 1/4 squared plus, and we replace y with the same thing, equals 4. You can think of this very similarly as 4x squared equals 4, and this will give us 16x squared plus 16y squared. I just noticed a little problem here. Should be y equals 4. Dividing both sides by 16, we get x squared plus y squared equals 1/4. Oops, 1/4. Well, this is now a circle with a radius of 1/2. So if this is 2, radius of 1, a radius of half, this circle is now compressed to that blue circle there. Okay, now we're going to see that we can apply dilations singularly, vertically and horizontally, even to non-functions. So here we go. Here's our relation. And we're going to apply a vertical dilation by a factor of 2. Vertically, we replace y with y on a. So this will become x squared plus y on 2 squared equals 4. This will give me x squared plus y squared on 4 equals 4. This cannot be simplified. Instead, we're going to see what this would look like just using the same principles that we've gone through with the distances from the y-axis. So here we go. So, if the distance from the y-axis is now 2 times the distance, let's consider this point here. If that is a distance of 2, it will now be a distance of 4 away. So it's 2, 3, 4. So the new point here is all the way up top. Similarly, this point here is a distance of 2. So it will now be a distance of 4. So that's 2, that's 3, and that's 4. So the new shape of this function is actually an oval shape, kind of like this. It's very hard to draw. Hopefully my drawing pad will do it for me. Whoops. Stretch this out a little bit more. There we go. So that is what it looks like if we vertically dilate a circle by a factor of 2. Let's do this again. This time, let's horizontally dilate this circle by a factor of 1.5. You can think of this as a factor of 3 over 2. So here's my relation, not a function. And to do this, we replace x with x over the factor that we want, 3 over 2 whole squared, plus, very similarly, actually, we can consider this as 2/3 x squared plus y squared equals 4. Expanding this, we get 4 on 9 squared plus y squared equals 4. Very similarly to this, we can draw this and think of this like the following. So now it is a distance from the x-axis. Okay, so this distance, if that was a distance of 2 times 1.5, should now be a distance of 3, so it should be all the way out here. Same with this distance here, if that's a distance of 2 times 1.5 should now be a distance of 3 out here. So drawing this out as an oval. Don't worry, hopefully my computer will do it for me. There we go. Let's rotate this a little bit. There we are. Come on. There we go. Adjusting this and adjusting this. And that is what a dilation will look like horizontally and vertically of a circle. Now consider that we can do this to a circle, meaning we can apply this to any shape that we want. And so I hope that gave you an insight into dilations vertically and horizontally onto non-functions. Hope to see you in the next video. Best of luck.